Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam, Madam.
Okay, how are you? How are you?
Good, Madam.
Good. Alhamdulillah. Okay, so let's start our class with Ummul Kitab Al-Fatihah. Alright, on Monday, we have discussed until SN1 mechanism, right? SN1 mechanism, example 7.8. Ini ke? Page 255. Ke belum? Saya dah confuse ni. So, saya declare lain kali. Oh, dia
Baru
base
sampai A, Madam.
baru sampai A, sampai 7.8 betul lah Betul Okay. So let's continue. Okay, with okay, this one we have discussed. Okay. With the rearrangement. Okay, so yang ini dia akan usah sikit je. Okay. So please listen carefully to my explanation. Okay, so that after this, if question like this come out in the examination, you can answer. Okay, rearrangement not only for haloalkane, we can also use the same type of rearrangement in other for other functional groups. For example, in the nucleophilic substitution of alcohol pun boleh. Okay, as long as the reaction involve the formation of carbocation. Okay, so sekarang ni dalam poll R 20 orang je jawab. Semalam berapa orang datang? 20, berapa ni? Dan sekarang dalam ni ada berapa orang? Only 29, sepatutnya 43, betul? Makin lama makin sikit, hilang terus. Okay, tak apa. Kita ajar orang yang nak belajar je lah. Okay, so look at example 7.8, page 256. Okay, maybe the space given is quite small. Okay, because there will be three steps of the mechanism. Okay, yang kita belajar on Monday, we have 2 steps. Okay, 2 steps yang mana yang ni, yang saya tulis di tulisan merah ni. Okay, so on Monday we have discussed there are 2 steps. Okay, general steps. Okay, but okay, when it involves rearrangement, we have to add one more step. Okay, before step 2, we have to do rearrangement. Okay, before we can do nucleophilic attack. Okay. So let's do the mechanism for this question. Okay, this is the question. Okay, so in this question, we have the compound called 1-bromo 2,2-dimethyl and 1-bromo. This is carbon number 1, carbon number 2, carbon number 3. 1-bromo 2,2-dimethyl propane. Okay. So we do a reaction called nucleophilic substitution reaction. Okay, so the Br will be replaced by OH. Okay, if we draw it directly, the product should be, kalau kita just substitute sahaja, sepatutnya macam ni lah produknya. CH3, CH3, and then CH2 ganti je lah Br tu dengan OH. This is what we have learned before. But this is actually the minor product. Okay, kalau kita ganti direct sahaja, we get the minor product. The major product is shown here in your book. Okay, also given the same structure, right? Harapnya dah betul lah. Okay, kita dah betulkan. Dulu salah. So this reaction actually involves a rearrangement reaction, okay, which is called 1,2-methyl shift rearrangement. Okay, where we will shift, okay, kita akan shift one of the methyl here to the next carbon. Okay, kita shiftkan methyl kepada carbon yang sebelah. Okay. Ini dah betul dah yang tu structure-nya. Kita tengok rearrangement. Okay, let's do the rearrangement. Right, how to do this? Okay, first step. Okay, just the same as what we have learned on Monday. Step 1. What is step 1? Step 1 dia apa nama dia? Formation of carbocation, right? Okay, formation of carbocation. Okay, so we draw the structure of the starting material that we have. Okay, CH3, and then we have C, CH3, okay, another CH3 here. Okay, it's bonded to CH2. Okay, maybe I can open up that structure. Kita buka sikit. So that you can see that that carbon is attached to which group of atom. Okay, so this one CH, okay, kemudian ada H, ada Cr. Okay, so in the first step, what will happen? Here we have only one molecule here, which is the haloalkane itself. Okay, the bond between C and Br, okay, C and Br has different in electronegativity. Okay, C is delta positive, while Br is delta negative. Okay, different in electronegativity. So the bond between C and Br will break heterolytically. Okay, heterolytically meaning we have double-headed curve arrow. Okay, and slowly, because we are breaking the bond. Okay, we are breaking the bond now. So it will form the primary carbocation. Okay, primary carbocation. Okay, let's draw. We have this structure. And the carbocation is here. Okay, so I will move the H to the right. Okay, saya ubah sikit punya structure dia. I want to put the positive charge below. Okay, saya letak positif tu dekat bawah ya. Just the same thing, tapi saya ubah sikit. Sorry. Saya nak letak positif kat sini. Okay. Alright, so let's show the H. So the H now, I move it here. Okay, I move it here. Okay, plus with Br minus. Okay, Br minus. Alright, so this is the first step. Can you understand the first step?
Yes.
Yes, okay. Let's go to step 2. Okay, step 2. Okay. We have to do rearrangement. Why we have to do rearrangement? Okay, look at the carbocation that we have formed. Okay, in the first step. Okay, the carbocation. Oh, saya padam semua. Astagfirullahaladzim. Tak apa, kita terlibat semula. Ibadah pula ya. Okay. Okay, step 1 tadi. Sekejap, saya tulis semula. Saya tulis macam ni lah. Okay. Okay, I repeat again. What happened in step 1? Okay, we want to form the carbocation C+. So C is delta positive, while Br is delta negative. Okay, so when the bond break between C and Br, all the electron in the bond will be given to Br. And this bond break heterolytically and slowly to form the carbocation and Br. Carbocation, which is the primary carbocation. Okay, why this is a primary carbocation? Okay, you can check here. This carbocation, carbon that has the positive charge, is attached to only one carbon. Satu je carbon yang sebelah dia. Okay, so this is a primary carbon. Okay, primary carbocation. Okay, at the adjacent carbon. Are you there, class? You
Yeah.
dengar saya ke? Dengar eh? Okay,
Dengar,
saya tutup video lah sebab nanti dia lag pula. Okay. Sekejap. Batas ni balik. Okay. Tadi saya berhenti sini eh. Sampai mana saya cakap tadi? Yang you all dengar sampai mana?
Primary.
Primary. Okay, yang tu sampai tu dengar. Okay. So sekarang ni, now we have a primary carbocation. Okay, because this carbocation is attached to only one carbon. Okay. And at the adjacent carbon sebelah carbocation ni, there are two methyl groups which can be used to make rearrangement. Okay, we can use one of the methyl groups, okay, to do rearrangement, okay, to form more stable carbocation. Kita ada primary, tapi kita tak nak primary tu. Kita nak yang lagi stabil. Boleh buat yang lagi stabil. So, we do rearrangement in the second step. So, dia ada rearrangement. Okay, so the rearrangement that we will do, because we have methyls, okay, two methyls, okay, at the adjacent carbon sebelah C plus ni ada dua methyl group. The type of rearrangement that we will do is 1,2 methyl shift. So kita akan gerakkan methyl group tu. How? Okay, let's draw. So we have methyl, okay, at the second carbon. And then at the third carbon, we have H and H. And also the carbocation. So what do we do? In 1,2 methyl shift, the methyl will move, okay, to the carbocation. Okay, the methyl will move to the carbocation. Okay, so we will have to draw like this. Saya lukis macam mana? Okay, you just have to move, okay, the methyl to the carbocation position. So maksudnya apa? Kita ubah tempat. Okay, yang ini akan tukar ke sini. Carbocation tukar ke sini. Methyl ni tukar ke tempat carbocation tu. Okay, so what will happen? We will get the more stable carbocation. Okay, so sekarang ni dia akan ubah. Jadi CH3, CH3 ke atas ni ada lagi. Okay, C ada 2H, still ada 2H. Okay, carbocation, the carbocation move here. Dia tukar tempat. Itu pindah sini. Do you understand the rearrangement here?
Yes.
Okay. So ubah tempat sahaja. Ubah tempat dengan CH3. So that's why the name is 1,2-methyl shift. Okay, 1,2-methyl shift. Okay, so this is the new carbocation, which is now, it is a tertiary carbocation. So kita dah dapat yang lagi stabil. Tadi primary. So kita tak nak primary tu. Kita nak yang lebih stabil. Tertiary carbocation. So barulah kita masuk step nombor 3. Okay, step 3, nucleophilic attack. Okay, so we will draw the structure of the carbocation that we got just now, which is the tertiary carbocation. Kita dah tak nak dah yang tadi tu. So ni CH2, CH3. Okay. Plus with, okay, this time we have the reaction with KOH. Okay, KOH maksudnya the nucleophile is OH minus. Okay, so we will use the nucleophile OH minus. So ini plus with OH minus. Okay, plus with OH minus. So what will happen? The nucleophilic site is attacked by the carbocation. Okay, ini akan diserang oleh carbocation. Okay, tengok arrow saya. Okay, daripada mana ke mana. And then the product will be formed. Okay, so this time we are making a new bond. So the rate of reaction must be fast. Okay, so the product we will have CH3, okay, CH3. Okay, so pada carbocation tadi masuklah dia punya OH. So CH2, CH3. So barulah kita dapat dia punya major product. Okay, get it? Right?
Yes.
Yes, okay. If you afraid that you will not copy the correct one now, I will send this picture to you. Gambar ni saya hantar bersama dengan inilah. Okay, nota yang saya hantar last on Monday ke semalam saya hantar. Saya akan update semula ya sebab ada kesilapan sikit. Okay, so this one is for today. Yang ini untuk hari ni yang kita buat tadi. Bawa satu dulu. So yang rasa tak berapa clear tadi boleh tengok sini. Clear. Okay. So that's the 1,2-methyl shift. Okay. Now let's do 1,2-hydride shift. 1,2-hydride shift involve okay, this reaction involve 1,2-hydride shift rearrangement. Okay, so the same thing happen. Okay, when we have this compound, okay, which is apa tu nama dia? 1, 2, 3, 4. Okay, we have 1 bromo 3 methyl butane. Okay, 1 bromo 3 methyl butane. When we do nucleophilic substitution, okay, we will get this compound. Okay, which has the CH3, okay, CH2, CH2. You will tend to substitute, just substitute Br with OH. But this is actually the minor product. Okay, so what is the major product? It should be this one. Okay, so how to get the major product? Okay, let's see the mechanism. Okay, let's see the mechanism. Still involve 3 steps. Okay, because we have rearrangement. Okay, so we start with step 1. Okay, the formation of carbocation. Okay, formation of carbocation. So we draw the structure of the compound, which is the haloalkane. Okay, we have H here. So I will draw like this. Okay, we expand a little bit of this structure. So let's say this is H, and this is the Br. Okay, so the first step involves the bond breaking. Okay, so the bond between C and Br will break. Okay, because they have difference in electronegativity. C is delta positive, Br is delta negative. Okay, so the bond between C and Br will break heterolytically. Okay, all the electrons in the bonding will be given to Br. Okay, so the carbocation will be produced. And this time we still have the primary carbocation. Okay, it is a primary carbocation. CH2, HN plus. Okay, let's say I open up a little bit of this structure. Kita buka sikit structure ni. Okay, to become like this. Okay, it has carbon bonded to 2H. Okay, the adjacent carbon is the carbon that has 2 hydrogens. Okay, so these hydrogens can be used to do rearrangement, which is called 1,2 hydride shift. Okay, 1,2 hydride shift. So we will do rearrangement. Why we need to do rearrangement? Okay, because we want to form more stable carbocation. Okay, we want to form the more stable carbocation, which is the secondary carbocation. Okay, let's draw. Okay, so we have the carbocation just now, which is a primary carbocation. Okay, so we will have to do rearrangement. Okay, so I open up this structure like this. Okay, because we want to show the rearrangement. Okay, we have H and H here. And then we will do 1,2 hydride shift. Okay, so what happened here? Okay, the H will change position with the C+. Kita tukar sahaja tempat H dengan C+. Okay, so C+ akan duduk sini. Okay, H akan duduk sana. So 1,2 hydride shift. Okay, tukar sahaja tempat. Okay, tukar tempat. Jadi, what will be formed? We will get the new carbocation, okay, which is a secondary carbocation. So, carbocation dia pindah sini pula. Okay, H ni ada kat sini. Ni akan jadi CH3. Like that. Okay, so this is a secondary carbocation, which is more stable than primary carbocation. Ya, sebab tu kita kena buat rearrangement. Okay, so this is a secondary carbocation. Can you follow until this step?
Yes.
Yes, okay. So next, okay, we do step 3. Baru kita buat step nombor 3, nucleophilic attack. Okay, nucleophilic attack. Okay, so in nucleophilic attack, okay, we will use the carbocation that has been formed in the step 2. So, kita guna semula carbocation kita dalam step 2. Okay, we have a secondary carbocation just now. Okay, it is here. Okay, and then yang ni tadi CH3. So, dia jadi CH3 lah. Tak payah kacau dah. Okay, and this carbon has 1 H. Okay, plus with the OH minus also. Mana dia tadi? Sekejap. Ni. Okay, the nucleophile in this reaction is also the OH minus. Okay, so kita masukkan OH minus di sini. Okay, so what will happen? This reaction is formation of a new bond, so the rate is fast. Okay, so the new product will be formed. Okay, so the nucleophile, okay, nucleophile is attacked by the secondary carbocation. Okay, So the reaction will form the new compound, which is the major product, okay, where we can see that the OH is substituted at the second carbon instead of the first carbon. So OH ni duduk di sini. This is the major product. Okay, get it?
Yes.
Any question? Ada soalan?
No.
No? Okay, I will also send this picture to you. Okay, this is the question. You may refer if you still haven't finished copying the answer. Okay, so this is the the rearrangement. Sekejap. Mana layout? Okay, so if you don't have any question, let's move to SN2 mechanism. Okay, nucleophilic substitution mechanism bimolecular. 2 means bimolecular. Okay, so in this reaction, okay, in this mechanism, okay, we have two molecules. Okay, two molecules in the first step, and actually there is only one step. Okay, dalam step pertama hanya ada satu step saja. Okay, and there are two molecules. There are the nucleophile and the haloalkane. Sebab tu namanya adalah bimolecular SN2. Bimolecular. Okay, so what happened in this reaction, okay, in this mechanism, okay, the nucleophile will be attacked by the carbon. Okay, so carbon and X, okay, carbon and X here, they have difference in electronegativity. Okay, carbon is delta positive, X is delta negative. Okay, so in this reaction, nucleophile will be attacked by the C plus, okay, or the carbocation. Sorry, the carbon, not carbocation, it is the carbon, which is the electrophilic side. So the bond between C and X will break temporarily. Break sementara. Okay, to form the transition state. Okay, where we have a negative charge, okay, carbon. Okay, sebab tu ada tanda negatif kat luar ni. So mungkin kecil sangat tak berapa nampak. Okay, tengok dekat buku awak ada tanda negatif. Okay, why negative? Okay, sebab carbon now has 5 bonds. 1, 2, 3, 4, 5. Okay, this is called a transition state. Okay, sebab carbon dia kena fikir nak pilih siapa? Nak pilih nucleophile ke nak pilih X? Okay, so after X leave the group, okay, the new compound is formed. Okay, senang je nak ingat. Okay, saya bagi kisah rumah tangga yang kedua. Hari tu kita kisahnya kita C dengan X dia bercerai dulu kan? Ingat lagi tak? Ingat tak cerita saya tu?
Ingat.
Ingat. Okay. So kisah rumah tangga yang kedua ni, SN2 ni kisahnya adalah karbon ni curang. Okay. Boleh ni ke? Boleh relate kan tak? Karbon ni dia dah kahwin dengan X. Dan dia dah ada anak pun. R, H, H. Okay. So karbon ni dah ada anak dengan X. Tapi dia curang. Dia curang dengan nucleophile ni. Dia yang serang nucleophile sebenarnya. Nucleophile diserang oleh karbon. Okay. So dia pun buat temporary bond. Sebab itulah bond kat sini dia putus sementara saya cakap tadi. Temporarily break. Okay. So you can see here the bond yang ada tanda dot ni. Okay. Itu temporary bond. So maksudnya sekarang ni karbon ni dia kena fikir dia nak siapa? Nak nucleophile ke nak X? Dia tak boleh dua-dua. Satu je. Okay. So what will happen? X is a good living group. Okay. Halogen is a good living group. So it will leave the group. So kat sini X ni berkorban lah kiranya. Okay. X berkorban. Okay. Dan dia pun tinggalkan family tu. Karbon pun kahwin dengan nucleophile. Okey, boleh ke?
Boleh.
Boleh Okey. For rate of reaction sama je dengan cerita yang dulu. When you want to break the bond, do it slowly. When you want to make new bond, do it fast. Okay. The one that I want you to focus is the shape of the haloalkane before and after the X leave the group. Okay. Before X leave the group, the shape is like this. Tengok sebelah kiri. Ini shape dia. Okay. After X or Br here leave the group, the shape becomes like this. Okay, and for this mechanism, it is compulsory to draw the structure of the haloalkane and the product using 3D structure. Ini satu-satunya 3D structure yang kita guna dalam mechanism. Okay, so if you see the structure of the starting material and the product, you can see that it turns the tetrahedron of the carbon atom inside out, like umbrella caught by the wind. Ya, macam payung kena tiup dengan angin. Ya, pernah jadi kat saya dulu. Sekejap, saya letak gambar di sini. Ada. Macam ni. Lebih kurang macam ni lah. So pernah jadi kat saya dulu, saya pergi solat dekat Masjid Nilai waktu saya duduk dekat Kajang. Okay, so saya berhentilah solat asar. So konon-konon ayu kan, pegang payung keluar, waktu tu hujan. Tak sangka pula angin kuat. So ada seorang budak lelaki, dia tengah pakai kasut. Waktu dia dah habis solat lah kot. Okay, so saya jalan, konon-konon tak nak basah lah pakai payung. Sekali tu payung saya ditiup angin, jadilah macam ni. Basah jugalah saya. Okay, so lebih kurang macam tu lah. Okay. So tengok yang ni pula. Okay, let's see this one. Okay, how the structure change. Okay, how the tetrahedron of carbon atom turn inside out like umbrella caught by the wind, like this. Okay, nucleophile is attacked by the carbon. Okay, and the transition state is formed. Okay, so this is the transition state where the carbon has temporary bond with the nucleophile and the X. Okay. So X is a good leaving group, so it will leave this family. Okay. Keluar, bila X keluar, the shape becomes like umbrella caught by the wind. Okay, so inversion occurs at the carbon. Okay, do you understand?
Yes, madam.
Yes.
Okay.
Yes.
Okay, right. Let's go to this one. So this one sama macam tadi juga. Okay. So relative reactivity of bimolecular nucleophilic substitution as reaction SN2. Okay, the reaction will be fast when the groups are small. Okay, and slow considerably when larger groups are attached. Okay, the presence of bulky alkyl groups. Bulky ni maksudnya apa? Bulky. What does it mean by bulky? Bulky alkyl groups. Bulky maksudnya grup yang besar-besar. Okay. It will prevent the nucleophilic attack. Okay. If you still remember just now, I have explained okay, that the reaction must be backside attack. Mesti diserang daripada belakang. Daripada belakang maksudnya apa? Okay, refer back to this. Okay, the position of the OH minus, okay, OH minus ni, and the Br mesti bertentangan. Okay, so OH diserang daripada belakang. Okay, diserang daripada belakang. So that's why I put the OH on the left side here. Okay, mesti belakang karbon. Okay, Br mesti bertentangan kedudukannya dengan OH minus. So that is the backside attack. Okay. So backside attack is can easily occur when we have small groups of atom attached to the carbon. Okay, for example, H. Okay, if you still remember just now, I said the carbon has three kids. Dia dah ada anak 3 orang kan, dia cakap kan. Okay, Br ni dia punya wife lah. Okay, so ni anak-anak dia. H dengan H. Okay, because we want to do backside attack, Okay, it is easily occur if we have a small group of atoms attached to the carbon. Okay, small group of atoms such as hydrogen attached to the carbon. Okay, the backside attack can occur easily. Senang untuk carbon menyerang dari belakang. Senang dia nak cheating lah. Senang dia nak curang dengan BR. Sebab apa? Anak kecil lagi. Okay, tapi kalau kita ada, okay, for example, one alkyl group, ni senang lagi. Masih mudah lagi sebab ada satu saja yang penghalang dia. Okay, one alkyl group, only one that will kira macam nak prevent daripada backside attack, but still can have the backside attack can still happen. Compared to if we have two bulky alkyl groups and three bulky alkyl groups. Okay, bila anak-anak dia semakin besar, semakin susah dia nak curang. Okay, so that's why SN2 mechanism can occur easily if we have methyl halide, methyl halide and primary halide. Methyl halide and primary halide can easily do SN2 mechanism compared to the secondary halide and tertiary halide. Okay, do you understand?
Yes.
Yes, okay. Can we proceed? Let's do this mechanism. Okay, so we have one carbon only. This is methyl bromide or bromomethane. Bromomethane. Okay, bromomethane reacts with KOH aqueous reflux. Okay, you just have to substitute the Br with OH. Okay, so this is SN2 mechanism. Why? Because we have a methyl halide. Okay, which is the most reactive compound towards SN2 mechanism. Okay, paling reactive. Okay, so let's draw the mechanism. Okay, how to draw the mechanism? Only one step of reaction occur in the mechanism. Okay, so we have SN2 mechanism. We have the bromomethane just now. Okay, bromomethane. So we have to draw in a form of 3D structure. Okay, so this is the 3D structure of bromomethane. Okay, so backside attack will occur. Okay, so the reaction nucleophile just now, kita refer balik sini, and the nucleophile is the OH minus. OH minus. Okay, so this OH minus will be attacked by the C. Okay, so C and Br has difference in electronegativity. Okay, C is delta positive. C is delta positive while Br is delta negative. Okay, C is delta positive. Okay, Br is delta negative. Okay, so OH is the group which has a lot of electron. Okay, OH minus. Okay, so this OH will be attacked by the C, backside attack. Okay, diserang daripada belakang. Okay, so what will happen? The temporary bond will be formed between OH and C and C and Br. Okay, and because this step involve the bond breaking, okay, walaupun hanya putus sementara dulu, it must be done slowly. Okay, so what will be formed? It will form the transition state. Okay, in the transition state, we will have the temporary bond between C and Br and between C and OH. And remember to put the negative charge, okay, at the outside the bracket because it is the temporary. Okay, carbon has 5 bonds, so it has greater electron. Okay, dia dah ada extra electron kat situ. Okay, so this structure is called transition state. Okay, ini kita panggil sebagai transition state. Okay, transition state. So carbon cannot become like this forever. As I said just now, okay, carbon must have 4 wives, not more, not less, or 4 bonds, not more, not less. Okay, so we will have to break the bond between C and Br. Okay, because Br is a good living group. Okay, so what will happen? Okay, tengok dia punya perbezaan. Atau saya klik kat sini lah. Okay, so the new product will be formed. Okay, where we will have the OH here. Okay, OH kat situ nanti. So H kat sini. So the bond, okay, between the carbon and H will have inversion. So it form like this. So tengok kat mana kedudukan H dengan H yang di bawah yang saya lukis tadi. Okay, so dia mesti berubah tempat. Okay, so right here we will have the methanol. So this is the product. Okay, so this is the mechanism of SN2 mechanism. Okay, do you understand?
Yes.
Any question? Ada soalan?
Tak ada.
Tak ada Okay, so tengok betul-betul Berhati-hati this one. Ini mesti ke sini, ke kiri sikit, yang ini ke kanan. Ke kanan. Ni ke kiri. Harap-harapnya faham lah apa yang saya tulis ni Yang tak masuk kelas tu tak tahulah. Okay, saya bagikan slide ini juga pada you all. Okay, and one more slide. Okay, so now let's move to the next question. This is the practice question. Yang ni saya nak awak cuba buat di rumah, di kampung. Okay, try to do this. Practice 7.2. Okay, this is practice 7.2. Okay. Question number 1 and then practice 7.2 question number 2. Okay, let's discuss this one. Yang ini mudah aja. Okay, let's do this one. Practice 7.2 question number 2. Okay, cuba kita buat. Okay, let's answer this question. A and B are positional isomers with molecular formula C4H9Cl. Okay, A is a primary haloalkane while B is a tertiary haloalkane. Okay, draw the structure of A and B. Specify which isomer undergoes SN1 mechanism and which isomer undergoes SN2 mechanism when reacted with OH minus. Yeah, so the nucleophile given is OH minus. Okay. So kita boleh jawab yang pertama dulu. Okay, what is A and B? Okay, A, dia kata apa? A adalah primary haloalkane. Okay, primary haloalkane. So if it is primary haloalkane with 4 carbons and 9 Cl, okay, we can have CH3, CH2, 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 okay, kemudian dia kata Cl. Cl. Cukup tak? 4 karbon, 9 H. Is it enough? 4 carbons and 9 hydrogens?
Yes.
Yes, yes.
This is the primary haloalkane. So what is B? B is a tertiary haloalkane. So kalau tertiary, awak teruslah buat tertiary carbon. Okay, maksudnya ada 3 CH3 around C. So Br duduk di sini. Br pula. Cl. Okay, Cl duduk kat situ. Okay. So is it enough? C 4 carbons and 9 hydrogens, 1 Cl. Cukup tak? 9 karbon. 9 karbon.
Cukup.
9. Cukup ya. Okay. So this is the structure of A and B. Okay. Now we want to know which one will undergo SN1 mechanism. Yang mana satu? A is primary, B is tertiary. Okay. SN1 mechanism. SN1 maksudnya apa? SN1, okay, it involves the formation of carbocation and we must have the most stable carbocation. Which compound can form the most stable carbocation? Is it A or B?
B. B.
B yang akan buat SN1. Okay, so maksudnya A akan buat apa dia keluar itu? SN2. Sudah jawab A dah. Okay. Draw the structural formula of SN1 product and write the reaction mechanism. Write the rate law of this reaction. Write the rate law. Okay. Show the series of steps in SN2 mechanism. Write the rate law for this reaction. Okay, macam mana jawab? Okay, B. Draw the structural product. Formula of SN1 product and write the reaction mechanism. Okay, make it a quiz. Okay, we have CH3, 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 and then we have Cl. Okay, reacts with OH minus akan dapat apa? Okay, it will give us CH3, C, CH3. You just have to substitute the Cl with OH. Okay, so this is the product. Okay, kita dah jawab dah. Product, dia tanya product, structural formula. Okay, write the reaction mechanism. Okay, so what is the reaction mechanism? We have 2 steps. Okay, step 1 is the formation of C+, carbocation. Okay, so we have to break the bond between C and Cl. Okay, in the first step, we break the bond between C and Cl. Okay, so C dengan Cl, dia tak sefahaman lah. Okay, so dia nak bercerai. So, bond dengan antara C dengan Cl ni akan break. Okay, so kita tunjukkan dengan arrow. Okay, C is delta positive, Cl is delta negative. So this bond break heterolytically. Okay, and then it will form the carbocation. Okay, form the carbocation and the anion. Okay, so this reaction is slow because we want to show the formation, the bond breaking. Okay, so we get the tertiary carbocation. So dalam soalan ni tak adalah kaitan dengan rearrangement. Okay, so kita dapat buat tertiary carbocation. Okay, and then Cl minus. Cl minus tak penting. Step 2, nucleophilic type. Okay, in the nucleophilic type, the carbocation will attack the OH minus. Okay, attack the OH minus. Okay, and this reaction is making new bond. Okay, and then the product will be formed. You have to show this arrow. Okay, so the product is the 2-methyl 2-propanol. So this is the mechanism. Okay, 2-methyl 2-propanol will be formed. Tengah-tengah tu C Okay. Tak habis jawab lagi soalan ni. Dia tanya apa tadi? Dia tanya what is the rate of reaction? Give the rate of reaction. Dia tanya. Give the rate. Mana ni? Write the rate law. Okay, so how to write the rate law? Rate law kalau ingat balik dalam chapter 3. Okay, sama saja macam yang kita belajar dalam chapter 3. Okay, to write the rate law, you just have to refer to the first step. Okay, remember rate determining step, it is the slowest step of reaction, slowest step of mechanism. So the rate law is rate equals to K times, okay, ni chapter 3 okay, times apa? The first compound that we have in step 1. The only compound that we have in step 1, which is okay, CH3, 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 Cl. And this is a first order reaction. Okay, so this is the rate law. Okay, boleh ke?
Boleh.
Boleh.
Okay, one more question. Satu lagi soalan tadi. Ini saya hantar kepada awak. Okay, one more question is, it asks us to show the series of steps of SN2 mechanism and write the rate law for this reaction. Okay, habiskan ya. Okay, let's do this reaction. So apa tadi dia punya compound dia tadi? Ada 4. Okay. For this reaction, okay, SN2 mechanism. Okay, how to write the mechanism? Okay, we have to draw the structure of the compound. Okay, kita draw sekarang. Okay, SN2. Okay, we have carbon that attached to Cl. Okay, that carbon is attached to CH2, CH2, CH3. Okay, and then it has the H. Ni ada H. Okay, kemudian dia ada H kat sini. Okay, and OH minus attack from the back. Okay, so what happened here? The OH minus is attacked by the C. Okay, OH minus is attacked by the carbon. So the bond between C and Cl will break heterolytically but temporarily. Okay, so what will be formed? It will form the transition state. Okay, transition state, where we have the temporary bond between C and OH and C and Cl. Okay, bukan Br, Cl. Dalam soalan Cl. Okay. So C here will have negative charge. Okay, because it has greater electron. Okay, dia akan ada lebihan, extra electron. Okay, so it will form this compound which is a transition state. Okay, ini transition state. Ada tanda negatif di luar. Labelkan transition state. Okay, so next step, we want to form the new compound. So Cl will leave the group. So when Cl leave the group, the inversion will occur. So, kita akan dapat structure macam ni. Okay, so this is the new product. Okay, so what is the rate law? Okay, kita tengok dekat step pertama dia. Okay, pada awal ni, yang ini, there are 2 compounds involved. Okay, so rate equals to K times, okay, the haloalkane. Okay, haloalkane tu apa? CH3, CH2, 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 Cl. Okay, times with OH minus. So this one is 1, 1. Therefore, the order of reaction is second order reaction. Okay, ini adalah dia punya rate law. Okay, habis dah jawab soalan ni. Senang sikit. Oh, tak payah jawab dah. Kena salin jawapan je lah. Okay. Okay, I will send this picture to you. So those who haven't finished copying, you can refer to the picture. Okay, last kali habiskan sini je. Okay, so comparison between SN1 and SN2 reaction. Okay, SN1 has 2 steps. SN2 has 1 step. Okay, SN1, 1 means unimolecular rate determining step. Okay, SN2, bimolecular rate determining step. Okay, SN1 is first order reaction. Kita dah discuss tadi dalam contoh tadi. Okay, first order reaction. So we can write the rate law as rate equals to K times the haloalkane. Okay, SN2 is second order reaction. So we can write the rate law as rate equals to K times concentration haloalkane times concentration nucleophile. Okay, SN1 needs weak nucleophile. SN2 needs strong nucleophile. Okay. And SN1 involve the formation of carbocation and carbocation can undergo rearrangement. Okay, SN2, no carbocation rearrangement because carbocation does not involve. And reactivity order, tertiary carbocation, tertiary haloalkane more reactive towards SN1, while for SN2, methyl or primary haloalkane more reactive towards SN2. Habis. Okay. Question? Dah terlebih masa 2 minit. Ada soalan? Ada soalan ke? Tak ada? Okay, kalau tak ada soalan, I think that's all for today. Okay, so please keep doing your practice question. Yeah, and also please do the group assignment question. Okay, yang dah buat, saya akan semak. Ada yang dah hantar, tapi saya tak sempat semak lagi sebab saya ada kelas. Okay, so I will mark your answer and give it back to you, and please finish doing your group assignment before the due date. Okay, and so this is the last class for before Hari Raya break. Okay, so we meet again after the Hari Raya break on Monday, insyaAllah. Monday, minggu 2 minggu lagi. Minggu lagi lah kot. Okay, seminggu cuti raya. Okay, minggu seterusnya tu kita jumpa balik. Okay, so that's all for today. Selamat Hari Raya Aidilfitri. Maaf zahir dan batin. See you again in the campus on week 15. Week 15, betul? Week 14, minggu depan week 14. Week 15. Okay, so that's all. We end our class with tasbih kafarah yang manas. Ada 35 orang je kat dalam ni. Yang lain dah raya dah kot. You all sepatutnya 43 kan?
26.
Oh, saya salah silap. Saya ingat 23 dengan 23 so 46. Okay. You may dismiss the meeting. You may leave the meeting now. Thank you for your attention.
Thank you, madam.
Thank you, madam.
Ya, madam.
Thank you, madam. Selamat
Selamat
Raya.
Raya.
Selamat Raya.
Selamat Raya.
Selamat Raya, madam.
Thank you, madam.